the last lesson of rationals first, only because it's a Friday and it's quicker to understand. So we're doing solving rationals. You did this last year. Okay? So example 1. What we're going to be doing on Mondays, we're going to be going over the graphs of rationals, which you did last year, but you only ever had certain vertical and horizontal asymptotes last year because we couldn't make the numerator anything but a number. We couldn't put variables in it, which we can this year. So it'll change. Example 1, determine the roots of the rational equation x plus 6 over x plus 2 minus 5 equals 0. A, algebraically. When solving rational expressions algebraically, what I always do is I, personally myself, get common denominators. So, and I think a few other teachers do it this way too. So I'm going to try and stick with the way that you've been taught, hopefully. So we have x plus 6 over x plus 2. And I'm going to move the 5 over equals 5. I like having it not equal 0 personally. It's just easier to deal with solving. It's equal to 0 because we're finding the roots, right? Normally that would equal y, correct? But it doesn't equal a y because we're finding x-intercepts or roots. I'm going to move the 5 over first. The only way you can solve rationals is if you have a common denominator. Okay? Right now the only denominators I have are 1, x plus 2, and 1. Because this would be over 1, this would be over 1. So whenever I have any polynomials, basically a binomial here, attached with a plus or minus sign, I put brackets around it because it is an entity. It is x plus 2. It will always be x plus 2, okay? You can't make it be x and plus 2 separately. They're not multiplied together. They're attached by a plus sign, okay? They're not coming apart. So if this denominator happened to be x instead of a 1, and this was x plus 2, the common denominator between them would be x and x plus 2. I'd have to times this one by x plus 2 and this one by x. You can't make them be each other. X plus 2 is x plus 2, okay? From last year. So the common denominator to these are x plus 2. So I'm going to times this one by x plus 2. I could technically times this one by 1, but that would do nothing. And then I have to times this one by x plus 2. So what you do is you can distribute in the numerator. You don't have to distribute in the denominator because your denominator is going to go away, which I'll explain in a second. So we're going to get x squared plus 2x plus 6 equals 5x plus 10. And technically this whole side's over x plus 2, and this whole side is over x plus 2. Now I say the denominators go away. Why is that true? Why can the denominators just go away and I have the top numerators left? If I said this to you, a over x plus 2 equals b over x plus 2, what would you say to me about the relationship of a and b? If I had a over x plus 2 equals b over x plus 2, what could you tell me about the relationship of a and b? They have to equal each other. If this denominator is equal to this denominator, then this numerator has to equal this one, correct? So could I not just write this then as A equals B? Yeah? Same thing here. If I have this denominator equaling this denominator, then I can just write x squared plus 2x plus 6 equals 5x plus 10. It must. Those numerators must equal each other. That's why the denominators go away. Before the denominators go away, though, you have to stop yourself and say, hey, I need to state restrictions. Because whenever you have a denominator with a variable in it, you have to state a restriction. Just like when we had a radical with a variable underneath it, we had to state restrictions. Okay? So, over here, I'd say my NPVs, remember from last year? X plus 2 can't equal 0. So x can't equal negative 2. You can check it and see if you're right. Negative 2 plus 2 would make this denominator be 0, which is an issue, so we're right. The reason why we have to check with our NPVs is, or we have to state our NPVs, is we have to check at the end for extraneous roots. If our root is an NPV, it doesn't work. Okay? So now we can just solve this. How do we solve anything with a squared? An x squared. Move everything to one side, set it equal to 0. That should be part of your being already, right? So minus 5. Really? Minus 5x minus 10. So you have x squared minus 3x minus 4 equals 0. And what do I do with this thing? It's trinomial here. Factor it. What times what gives me negative 4? What plus what gives me negative 3? X minus 4, x plus 3. I don't have to, or x plus 1, sorry. I don't have to do decomp because there's a 1, a positive 1 in front of the x squared. If there was a negative 1 or there was a number, I'd have to do decomp. So I get x equals 4, x equals negative 1. I check my NPVs. Are either of these my NPVs? No? So they should be good. So x should equal both of those. We're going to check it graphically. Now the reason why I can check this graphically is the entire equation only contains the variable x. If I had another variable in it like m or a and an x, then I couldn't do it, right? But because it has only an x, then I can punch it in. So I just type my original in. So x plus 6 over x plus 2 minus 5 equals 0. y1, y2. Whenever my y2 is 0, I always make it thicker so I can see it on the x-axis. How do I have to punch this ugly looking thing in there? It needs to be in its own brackets because it's fractions, but what else has to be in a bracket? The x plus 2 because it's a binomial. So you're going to go x plus bracket 6 divided by x plus 2 bracket minus 5 equals y2. And we're going to find the x-intercepts where they cross. So try it out. My calculator that I pull up normally is busted, so I can't do it on my screen. So this graph looks something like this. So we have y2 is this, y1 is this, and they cross the x-axis at -1 and 4. So we know we're right. What if I give you this? It's example 1. Example 2. Solve x squared minus 3x minus 7 over 3 minus 2x equals x minus 1 algebraically and check graphically. Remember the 3 minus 2. I literally just went to do a bracket. 3 minus 2x should be in brackets. Because it's together. So what common denominator do these two have? 3 minus 2x and 1. What's their common denominator? 3 minus 2x. So we're going to get x squared minus 3x minus 7 over 3 minus 2x equals x minus 1 over 1. And then I'm going to have to times this side by 3 minus 2x. Now, before I cancel off the denominators that say they're the same, remember I have to state non-permissible values. My NPVs, my non-permissible value, for this one's going to be 3 minus 2x can't equal 0. 3 minus 2x can't equal 0, then I solve for it. So I get negative 2x can't equal negative 3. Divide by negative 2. X can't equal 3 over 2. So if x did equal 3 over 2 or 1.5, it would be out. Try this one out. Okay, so the top you're going to get x squared minus 3x minus 7 on this side doesn't change. This side you're going to get 3x minus 2x squared minus 3 plus 2x. Now they're both over 3 minus 2x, so I'm just going to drop off the denominator. I'm going to move them all to the left-hand side, just because then I'll get a positive x squared, which I like better. So positive 3x plus 2x, I'm going to subtract 5x. Add 2x squared. Add 3. Negative 2x squared plus x squared is 3x squared. Negative 5x minus 3x is negative 8x. Minus 7 plus 3 is negative 4 equals 0. Now we have to do decomp because we don't have a 1 in front of the x squared. So what multiplies to give me negative 12 and adds to give me negative 8? What did I say? Negative 12 and adds to give me negative 8. Is there anything? So what do you have to do? Now life would have been so much better if this was a positive 4, because then it would be 6 and 2. That would have sucked if I did the whole thing with 1. So x equals negative b, so plus 8, plus or minus the square root of b squared, negative 8 squared, minus 4 times a times c. Remember what's great about this formula? You're given it on your formula sheet. That's what's great about this formula. Then 2 times 3. Now, some people at this point will punch it into their calculator. You're not proving it algebraically if you're punching this into your calculator, just so you know. That's like partial algebra, partial graphically. Okay. So then x equals 8 plus or minus 64, 48 over 6. X equals 8 plus or minus 112 over 6. What perfect square does 112 break into? Anyone? Yeah. 11 and 112? 121 is a... It's 16. So over here, I'm going to do this. Root 112 can break down into root 16 times 7, right? Because 16 times 7 is 112. Take this 16 out, and it becomes a 4. Goes away. I'm left with 4 root 7. X equals 8 plus or minus 4 root 7 over 6. Then I ask myself, if there's a number I can take out of all 3, I do. So if it's 3 or none, if you can take it out of all 3, you do it. If you can take it out of 2, you don't. So I can take a 2 out of here, here, and here, correct? So I can reduce it. If you take a 2 out of 8, it's 4. 2 out of 2, or 4 out of 2, it's 2. And 6 out of 2 is 3. So I'm actually left with 4 plus or minus 2 root 7 over 3. Now you guys, if they say what's the solution to this equation in a plus or minus 2 root b over c, and they ask you for a, b, and c, and you're a calculator person, and you're just going second trace 5, enter, 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 second trace 5, enter, you're never getting it back into that form. It's just not going to happen. So you'll never get that numeric response right. Okay? You also won't get it as a multiple choice correct, because you won't even know how to work it back, because you can't. Okay? So you have to be able to do this the long way. Last one. And this is literally just from last year. It's all the same thing over. You were taught this last year. Just repeating. Solve x over 2x plus 5 plus 2x equals 8x plus 15 over 4x plus 10. Algebraically. So this one I find that people will multiply the second and third term by 2x plus 5, and then they'll multiply the first and second term by 4x plus 10. You have to catch something that makes this a heck of a lot easier than that. 4x plus 10, what can I take out of it? A 2. What's left behind when I take a 2 out? 2x plus 5. They're actually very similar. They're almost close to the same denominator. So if I have x over 2x plus 5 plus 2x over 1, technically, equals 8x plus 15 over 2 times 2x plus 5, my common denominator is 2 and 2x plus 5, right? So what's this one only missing? It's not missing 4x plus 10. It's only missing a what? A 2. Anything with a 1 is missing everything. So I'm going to have to multiply this by 2 and 2x plus 5. And this side's good. It has everything. So if you don't spot that, take the 2 out deal, it's a way uglier thing. You're going to get a trinomial in there. It's not going to be fun. So on the top here, I get 2x over 2 times 2x plus 5. This one, I'm going to get 4x times 2x plus 5, because I can put these together, over 2 times 2x plus 5. Equals 8x plus 15 over 2 times 2x plus 5. Now, because the 2 on the left have common denominators, I can put them together with the plus sign. There is a catch, though. I want you to think about this. If this is a subtraction sign instead of a plus sign, so as an aside, you don't need to write this. I just want you to pay attention. So say if it was actually like this. Don't write this because it'll confuse you later as to why this is. But say instead of a plus sign, it was actually a subtraction sign. What does this subtraction sign do? It subtracts everything after. So what you'd actually get, I'm going to erase this, don't write this. What you'd actually get here is a negative 4x times these two, correct? So you'd end up with, or you could leave it like this. You could do it this way first if you want. I'll show you this way first. You could go 8x squared plus 20x over this. But when you subtract rationals, remember that when you subtract, this subtraction sign goes to all the terms after. You're subtracting every term after. So actually, what you'd have then, when you put them together, is you'd get 2x minus 8x squared minus 20x. Everyone forgets to distribute. They put it to here, but they forget to distribute it to this one. Remember, all the terms after a subtraction sign, that has to go with it. Remember, that's a common error that happens. Every one of us teachers knows that. The moment we have a subtraction sign in there and a binomial after it, there's a good chance we're losing a few people because they'll forget to distribute the subtraction in. Now, this one didn't have a subtraction. I just wanted to show you that because that's where people error. Additions, no one ever errors because it doesn't change anything, right? So here we're going to get 2x plus 8x squared plus 20x over 2 times 2x plus 5 equals 8x plus 15 over 2 times 2x plus 5. Now you take the 2x plus 5, can equal 0, because we're going to have to do MPVs before we get rid of that denominator. 2x can't equal negative 5. X can't equal negative 5 over 2. Don't know why I did that again. And then numerator equals numerator. 2x plus 8x squared plus 20x equals 8x plus 15. In order to solve a quadratic, anything with an x squared, you have to set it equal to 0. So I'm going to subtract the 8x, subtract the 15, and I get 8x squared. 22x minus 8 is what? Positive 14. X minus 15 equals 0. So you're trying to figure out what multiplies to give you negative 120 and adds to give you positive 14, and it's 20 and 6. So what times what equals negative 120? What plus what equals 14? It's going to be positive 20 and negative 6. We have to decomp. You can't just go x plus 20, x minus 6. If you're still doing that, stop. You have to stop. Stop the madness. Do decomp. So 8x squared plus 20x minus 6x minus 15 equals 0. Take out a 4x, and you're left with 2x plus 5. Take out a negative 3, and you're left with 2x plus 5. 4x minus 3 equals 0. 2x plus 5 equals 0. X equals 3/4. X equals negative 5/2, which seems very familiar to me because it's my non-permissible value, so it's out. That's my answer. all of these, I want you to just do B and D. Seven, 8, okay.